In our first example, pinapahanap sa atin yung volume of a solid generated by revolving about the y-axis, the region bounded by the graph of y equals 3x minus x cubed, the y-axis, and the line y equals 2. First, let's plot the graph and the region, then let's draw the solid of revolution. Looking at the region, pwede naman tayo gumawa ng rectangular element of area na perpendicular sa y-axis. Di naman siya mapuputol unlike dun sa illustration natin sa previous video. However, we need an expression of x in terms of y. Meaning, kailangan nating i-isolate yung x sa equation na y equals 3x minus x cubed. At hindi siya madaling gawin. So, this is another problem where using the cylindrical shells method to generate the element of volume can be applied. Let's start by plotting the rectangular unit of area, which is parallel to our axis of rotation. By that, I mean the y-axis. And generate the cylindrical shell, which will be our unit of volume. Yung volume niya, we will indicate as delta V. And it is equal to pi times the quantity outer r squared minus inner r squared times the height of the cylinder. We factor yung outer r squared minus inner r squared and rewrite the result, knowing inner plus outer radii equals twice the middle radius. And outer minus inner will be written as delta r. Rearranging the factors, pwede nating isulat si delta V as 2 pi rh times delta r. For a specific example, delta r is equal to delta x. So we need to express r and h in terms of x. R is equal to x, and h is 2 minus y. Hindi pwedeng y lang kasi yung distance, yun yung from the graph to the x-axis. Yung gap sa baba ng rectangular area, yung y. Kaya yung height nung cylinder natin ay equal sa 2 minus the quantity 3x minus x cubed. Sinusukat natin siya galing dun sa boundary niya sa taas. Using the values above, masusulat natin na ang differential volume dV ay equal sa 2 pi x times the open bracket 2 minus the open parenthesis 3x minus x cubed. The total volume is the sum of all the differential volumes and is equal to 2 pi times the definite integral of x times the quantity x cubed minus 3x plus 2 evaluated from 0 to 1. At this point, the remaining steps are just an application of the power rule and the second fundamental theorem of the calculus, leading us to our result of 2 pi over 5 cubic units. Our next problem is asking us to find the volume of the solid generated when the region bounded by y squared equals x and y equals x squared in the first quadrant is revolved about the line y equals 1. Let us look at the graphs and the region. Then at the solid of revolution. Now let's draw the rectangular unit of area. Kung gagamit tayo dito ng cylindrical shells, dapat yung rectangular unit of area parallel sa axis of revolution. Let's sketch our cylindrical shell and label h and r. Our formula for delta V is 2 pi rh times delta r. Delta r corresponds to delta y. R is equal to 1 minus y. Kasi radius here is measured from y equals 1, hindi from the x-axis. And h is the difference of, quote, the upper function, which is yung nasa kanan, minus the, quote, lower function, which is yung nasa kaliwa, or h equals the square root of y minus y squared. Yung square root of y galing sa y equals x squared. So, dv is equal to 2 pi r, but r is 1 minus y, times h. But h is y to the 1/2, minus y squared times dy. Yung total volume natin ay yung sum ng lahat ng differential volumes, or 2 pi times the integral of the product of 1 minus y and the square root of y minus y squared evaluated from 0 to 1. Again, at this point, we have already correctly set up the definite integral And we'll just fall back on what we know about evaluating the definite integral to lead us to our final answer of 11 pi over 30 cubic units as the volume of our desired region. And so, I'll end here with an encouragement for you na mag-practice naman kayo ng ibang problems on your own. You have your books and you have your learning guides. So, ingat tayo lahat at salamat sa pakikinig.